NRF board tonight. We've been away for about a month, but we'd like to get back to actually creating something here. Working on our Bluetooth toy. And so what we're going to do tonight is set up the build tree for our project. Make sure that everything that we want to do can be done. So we have an includes folder at our top level. I also want to make a source folder. And this is where our source, and of course I just made a non-source folder. I made that. All right, you couldn't see that as technically a separate window, but I was deleting that file. We're going to make a folder here, src, and inside that folder we're going to put, just call it main. It doesn't really matter what it is, just needs to be there. And let's see, we have our custom board. The main's going to have some stuff in it. We can go look out here in this external and we can take a look at existing examples. And we can find out what main has to have in it. So we have here, this is Blinky. That's the main from Blinky. Let's see what's the top of Blinky. Okay, this is actually pretty great. We're just going to need these lines. That'll be easy. We can do that. And we'll put those in here. I actually don't need standard int and standard bool right now. Just because those are files for doing this in C, and I'm really going to try to do this in C++. I know that the memory maps for this board are suitable for C++ because it's designed to be programmed with the Arduino toolset, and that's all C++. So I think we're good on that front. Okay, so there's our main. And we'll just set up our main function so that it's got something. Set up our forever loop. That'll get us something to go with. It's not going to do anything, but that's all right. We don't need it to. And we're going to try to get this to just do the basic things that we were expecting from our board. So we need it to do board init. Tell you what, I'm going to save a lot of back and forth. We're just going to copy this all over. And so that's what we've got there. So this up here, this initializes the board, gets all the proper registers set up and like that. This is going to run forever, and it's going to run through the number of LEDs, which this board technically only has one. If you look in the camera there, you can see the little red blinking light. That is the one LED as far as this board is concerned. And it's going to board LED invert and wait for 500 milliseconds. That's half a second. So pretty simple basic stuff. This program or a variation on it is running on there right now. What's running on there is the blink routine from the Arduino sample sketch. I was trying to figure out how to flash the board this week, and there's a short video out there on that on my YouTube channel, about 3 minutes, and it'll tell you how all that works. So let's see, we've got our C file. That's all straightforward. The next thing we really want to pull up is the hard stuff, our make file. So we will get our make file to be a little bit nicer, or existing at all, might be a better way to describe it. And so we can go back to our example make file. So over here in the Blinky example, The make files live under these folders that are designed for specific boards. Our board is most closely equivalent to the PCA 10056 board. It uses the same processor as ours does. And we're using ARM GCC, so that's nice and easy here. We have our make file. We're going to copy this make file over. There's some things we're going to have to change in here, but it's honestly not that big of a deal. There's stuff I don't care for. Well, for instance, I really don't like that we're calling Java. I guess we'll live. We're calling this NRF JProg. I know for a fact I don't have NRF JProg on here. We're going to figure out how to get NRF JProg though. That'll be something we do tonight. That'll be fun. Anyway, let's copy all this good stuff out. And there's just a bunch of this that we're going to change up because we don't care about it. It's not what we do. And that's okay. We are good with doing things differently here. Alright, we go back in here. Let's create ourselves a make file. Ultimately, this is probably going to become a CMake file, but right now, I don't want to have to think too hard. It's been a long, stressful week, what with the election and all that. I want things simple. And so that's what we've got here. Okay, so SDK root, that was something several layers up. 1, 2, 3, 4, 5, 6 layers up from our example. So our example make file. So let's go look and see where that puts us. All right. So from there, it would put us up into the blank folder. Yep, because we were in ARM GCC, was to the blank. That's 1. PCA 10056 is 2. Blinky is 3. Peripheral is 4. Examples is 5. NRF SDK is 6. Oh, that's perfect. That's perfect. Okay, so that's really easy for us to get then. We're going to make... yeah, that's externals NRF SDK folder. That's great. We can do this. From SRC, I want a top level make files, what this means to me. Put a make file up here. And this is one of the reasons we'd really like CMake. Once you're using CMake, you have a definitive reference for the top of your project. But, what do we call that? SDK root, okay. So we could define this at the top level as CMake file. We'll probably, just seeing how this is going to go, we're probably going to make this into the SDK file really quickly here. SDK root equals external slash, you know what? We have a command line. I see no reason not to take advantage of this command line. I can do a copy paste right there. And we'll copy that and I'll put it up there. That did not do what I thought it was going to do. Alright, let's try that again. That only did was an interrupt. Control-Shift-C, just like everything else in Unix at the terminal. Okay, that's much better. And I don't really like that folder naming, but that's going to do for now. I don't need to get too much more in depth about that. So, I'm going to make an all target. And there's probably other things that I want in here, but for right now, this is going to do me. We'll do it like this. And CMake-C SRC. And we're going to define SDK root equals SDK root. There, that ought to do us nicely. Oh, that's not going to end well for me. It's going to change into there, and it's not going to have the right path. Okay, so we're going to turn this into CMake right now, just so we get all those things that we're looking for. But I've got this information written down, so I've got a make file there. We will create a CMake list.txt. And I need to go copy a little boilerplate out of this. I'll tell you what, I will take you over to my browser window and show you exactly the sort of thing that I do with this. We're just going to go over to another project and steal their boilerplate. In fact, I think we're going to steal the boilerplate from a project that we've been working on. Oh, you know what? The Stormlight project used CMake. We did testing and everything in there, so that's awesome. We're just going to take all the goodies out of Stormlight. Fine, okay, so we're going to leave some of that out, but we do need our CMake minimum required version. And in fact, I'm going to change the CMake minimum required version to 3.16 because that is the version that gives me the ability to download dependencies. Let's see what version of CMake we have. We have 3.16, so we're in good shape here. All right, I thought that was the case. And I'm sorry, you actually can't see me pasting that in, but tell you what, I'm just going to go like that. You can just watch the screens then. It's maybe not as articulate or as elegant, but it's what we have. If you look there at the camera too, I guess I wanted to point this out. I bought myself a new toy. If you're a streamer, the Sony a6000, I guess, is a pretty well respected camera in the field. And right now, Sony has a really good deal on them. They're $100 off. So the camera with the lens is $550. And then for about another $140, you can get all the components you need to hook it up for a streaming camera. So for $700, I got an amazing streaming camera. You notice you can see the details on the board right there. That never happened with the webcam. That webcam was really tedious when I was running workshops with soldering fine components onto a board. So having this new camera with better focus, it doesn't get the bad glare off the LEDs. This is just great. Okay, all this stuff here we don't need. We do need. We need a project line, and we're going to jump over here and put that back in. Put that in here. You'll notice up here I changed the version to 3.16. Languages are C and C++. And is there any other fun stuff I have in there? I don't really have a lot of other fun stuff in there. Some of this kind of thing I'm going to have to put in. There's a more elegant way to do it than this setting a flag. Now that I know. So I can actually set I can ask it if I'm cross-compiling. Okay, and honestly, I don't remember the full syntax for that variable, so we're going to go look it up. We'll look up the cross-compiling variables. My absolute favorite thing about CMake is it's deeply, deeply documented. Make is too, but I find it just a little bit harder to. All right, so this variable we set to true. That's what I wanted to know. And let's just set these here where they can be viewed by each other. And I'm sorry, I've just set VS Code up so that it blocked things. Okay. So cross-compiling is one word. I have to put it in the brackets. Okay, and in here we have to do some stuff. So I think that's mostly, I think I actually don't need to put that in this file. So let's just cut that out. I think that's going to go somewhere else, but I'm not going to sweat that right now. Oh, no, I did need that. If I am cross-compiling, I need to add subdirectory src. That's what that's about. Okay, and I need to, whether we're cross-compiling or not, I need to set an SDK directory variable, and that is going to be, I'm just going to go look up here, and I want to CMake variables. There we go. There's a whole long list of predefined variables. And I want variables that describe the system. Alright. CMake projector. CMake. Alright. Well, I may just have to actually read through these. It's occasionally been the case that I've needed to read the fine manual. And I think this is one of those cases. It's a horrible situation to find myself in, but it's what I've got. CMake root, that's a possibility. Project source.dir, that's what I'm looking for. Alright. There we go. Project source.dir. Okay, and so it's project source directory / external / I am not copying that horrible directory name over. There we go. That's it right there. Okay, so that's our top level source dir, and that'll mean that we always have this SDK dir variable defined. And that's just going to make our life a little bit happier. Or SDK root. Let's do that, SDK underscore root. And that will make it a lot easier to copy everything out of that make dir. Okay. And if CMake cross compiling at the subdirectory source. Alright, that's good. We haven't added a test subdirectory yet, but we will. And we won't be cross compiling when we build the test subdirectory. So that's why I have that differentiator there. Alright, so that's that. So now I can go into the source folder and I can make a CMake lists folder or file. There we go, there's that. CMake list. Oh, I'm just going to copy a whole bunch of things here. This is all my SDK source here. Okay, and project directory, that's this folder. Yeah. Well, actually, that's kind of lovely. Just copy that whole thing, and I just have to change a couple of things. That's what I like about it. Pardon me. Didn't mean to snort on microphone. Okay, there we go. That's the usage of that variable I was looking for. Yep, that's it. Okay, so for each of our targets called define target. So there's a function called define target somewhere. I'll have to go dig that up, but I'm not that worried about it right now. So let's go get our special magic variables defined. Alright, we have a variable called linker script, and that's actually not going to get used in our main CMake, so I'm not going to sweat that one. Oh, our top level CMake though does have a real issue. It's not Stormlight, it's Blinky. It's not going to be Blinky though, so Bluetooth toy. Let's make that clear. You know, there might be multiple projects in here at some point, so maybe I should be more careful about using project and instead use... I wonder if there are more appropriate variables. Alright, project source directory, project name. You can make multiple projects, and that's always kind of a dangerous thing to do. CMake source dir, that might be the right thing. CMake source dir is what we should do instead of CMake project dir. So every time we use a project keyword, that actually would change. And so we don't want to go breaking that. Okay, we're going to copy a whole bunch of stuff out of here, and we are going to turn it into a variable. So we're going to take this source files variable, which includes the main.c. So I'm going to change that up a little bit, but we're just going to copy this, and that'll give us a good start. What's that? That's copied in here. And we're going to set source files, and it's not going to be source files. It's going to be SDK files. We don't need to do that plus continuation thing because we're in CMake. It just automatically assumes until I close that last little paren that I am obviously continuing my command. Okay, we don't want that at all. It's not our friend. And we're going to change all instances of $SDK root to curly bracket SDK root. There are 18 instances, and because I Didn't have anything else in here. I knew I couldn't be accidentally grabbing the wrong one, so that's great. So we got that. And let's see, what else do we have in here? We have our include folders. We better get that straight. So let's copy all of that stuff. There might even be a magic variable name I can use to make this happier, but I've got a bunch more of those. There goes that. We're going to set. And just like before, we're just going to get rid of all of those things. And this is, it becomes CMake currenter. CMake current source dir. There we go. Just giving you a little bit better view into. I'm going to take that camera off. We aren't flashing to that right now. But that hides my desktop, so I'm sorry, never mind. There we go. That's what I wanted to do. So this becomes, let's see, current source directory. We have to be, the source directory and the binary directory are just going to be different. There's nothing we can do about that. There's this config directory. I don't know what to do about that. We're just going to leave that alone for a minute. And a lot of this is going to get put into, there's something called a toolchain file. And that's where you would define all of this kind of stuff that is only needed when you're doing the cross compile. We just don't need it for other things. It clutters up this file. We can keep that all in one place. It's going to make everybody happier. I do a separate toolchain file for each project, so it's not like I'll be polluting up a global toolchain file. Alright, let's go investigate what that config folder is all about. Hey, look, config folder. I don't think that's us. I think that's down here under examples. And peripheral, Blinky. Oh, it could be. I don't see a config folder here. Oh, it could be under here. I'm sorry. Okay, it's under the blank folder. It's not part of ARM GCC. It's part of config. Listen here. So there's an SDK config file. And this SDK config. Now there's an app config folder somewhere. Alright, so it's going to enable our block allocator. I'm not sure what that is, but it's a thing we'll have. I have head and tail guard words for the config section. Enabled. Memory objects enabled. String error will be enabled. fprintf will be enabled. Oh, we better have all the good toys. Log not enabled. It's all right. This isn't the sort of device that would have a useful place to log anything anyway. Message pool element size. Huh, I wonder what that's about. I'm also pretty sure I shouldn't go playing with these things. I think it'll make my life unhappy if I do. Log CLI commands. We don't have CLI commands, so it kind of won't matter. And let's see. Some of these things might change if we were to build this under RTOS. And our final object, we actually will be building under FreeRTOS, so that is fine. There's a lot of stuff in this file. My takeaway out of this is that, yeah, we're going to need this file. And I'll tell you what, instead of having it in a config folder, we got one project in the thing, we're just going to put it right in the source folder. Oh boy. I just tried to copy and paste that. I don't think that's going to work out well for me. I'm just going to make an SDK config.h. And it's going to contain everything that's in here. And this should really go into our include folder, but we aren't quite there yet. We will get there. In fact, let's go do that right now. Take a look at our Git status. I'm sorry if anybody's been... Okay, nobody's been asking me questions in the chat, so it's not a big deal. Just realized I hadn't been monitoring the chat at all. But if you do have questions about what's going on, or if there's things that you want to see, go ahead and just put that in the chat. That'll be fine. Alright, I'm going to put that in the includes folder. And that'll make life just a little bit cleaner down here. We've got our includes, we've got our custom boards. And this custom board, I'm not sure how much we need this custom board, to be honest. Oh, we do need it for some. Our board looks like it looks like a standard dev board from a lot of aspects, but there are some things that are changed. We have a different number of LEDs. The regular dev board has something like 4 LEDs. We have 1. We actually have more analog pins than this too. If I switch this back over to, I'll switch to the pure camera. You can see things there as high as A9. You know, we were showing A5 as our highest A pin. But if I look right there, we've got an A9, and it kind of looks like that must be a temperature sensor. So, you know, we definitely need to push stuff up there. I'm not sure exactly how we're going to get all that information, but we aren't using all of it right now, so it doesn't matter as much. But it might be fun to do that, to add that to our game. We can see if it's really hot or cold. In any event, we can use all of those kinds of things for our game, and we can get all of that information from the Arduino support modules for this board, because they have had to work out where all this stuff is, and all that stuff was done by the manufacturer of the board, so I think we're good. Yeah, see, we've got A8. This is some sort of light sensor. It's kind of an exciting amount of stuff we can do with this board. As this project progresses, I'll be excited to see what we can play with here. It's going to be fun. All right, let's go back to the code. In fact, I'm going to go just code only for a minute. We can pull all of this stuff from the Arduino people. Adafruit. They have it for us. As you can see, though, obviously they've actually already set up a whole bunch of stuff. They obviously had the idea in mind that we would use Arduino with even their raw development board. But anyway, so there's our custom board.h, our SDK config.h. All the way down to the bottom of this, what exciting things do we have? Yeah, timestamping of the logs that we are using. Transport config debug color. Don't care. Yeah, a lot of stuff we don't care about. A lot of stuff around logging, and we don't plan to log. Alright, so we're just going to ignore that SDK config file. But we know we're going to need the SDK config file. That's definitely a thing. And up here at the top level make file, we can actually... Oh, I'm sorry, not the top level make file. We already established we're burning that top level make file to the ground. Let's just do that right now. Move that to the trash. Up here, we can tell this that include directories always includes make source dir / includes. So anything that's in an includes folder is automatically present for everybody. So anything that we need to define that's just for us is going to be in there. That'll be fine. Okay, this is the make file. This is the source make folder. Okay, so we can take... That was all just a complicated way of saying I'm taking that stuff out of there. I actually don't want to include the CMake current source dir. I went to all that trouble to look it up, and it turns out I don't need it. These are all SDK includes. So let's mark that appropriately. We'll go over here where we defined all those things. Alright, lib files, we don't have that. Optimization flags. Optimizing kind of terrifies me at this level, but we'll look and see what those will give us. We've got a bunch of things we have to define down here, and that's fine. These are all... Yeah, these are all things that really belong in the toolchain file. We've got a bunch of flags for our assembler down here. Oh, we've got a bunch of LD flags, which I guess we kind of knew about. We've got our linker script. We've got to put that in. That definitely belongs in the cross compile, in the toolchain file. Here's some things about our specific target that are getting put in. So we've got heap size, stack size. Got our library files, library linkers that we're going to get put in. Default target. I don't think that works the way they think it does. That is multiple steps down. It's below that. It's not going to lead to a happy result at all. Include template path, makefile.common. That's going to be a sore spot. Alright, SDK root components, toolchain GCC. Let's go take a look what's there. Components, toolchain, GCC. And there is a makefile.common. Yeah, I bet there's some other stuff in here we'll wind up with too, but A lot of noise up here. Okay. Suffix files. Alright, it's not going to try to make dependency files. It's going to mark them as precious. I don't actually know what that means, but... Okay, this is just a lot of boilerplate that I don't care about. It's really about... Toolchain config files, make file.platform suffix. I'm building on POSIX right now, so I might need to look in there and see if there's anything I need to know about. Yeah, this is just, this file is actually doing all the things that I would do in a toolchain file. A lot of them are handled for me, so I'm not going to sweat about them. Yeah, the stuff about here about get object files, that could be a thing. Alright, let me see. Define target. This was the thing I was a little worried about. Alright, this is just saying we have a variable called output file. This is the build folder. I'm going to strip the name down. It's a dot out. Oh, that depends on it. Or that's a target that depends on or creates dependencies on dot out, dot hex, dot bin. So those are things we're going to create down here. And there's a prepare build option here. There's prepare build. That's going to get all our object files. That's adding just a lot more complexity to this than I want. I'll have to see what gets us a dot hex and a dot bin and all that good stuff. There we go. There's our rules for dot out and dot bin. Alright, and it's just to compile with the LD flags, the LD input. And among other things we're saying I want a .map, I want a map file. That's cool. I like map files. They're fun. So it's nice to see where stuff's getting shoved. The bin file, we're just doing an object copy with a binary output. That's fine. That's pretty normal. If you haven't done that before, object copy, a compiled executable contains a lot of stuff that ultimately doesn't need to be on the final object. An object copy strips that out and puts it into a format that can be understood by programs that upload these hex files. And this goes from the .out file. So that binary file is going to be, well, that's going to just be raw. Okay. It still strips stuff out, but. And the hex file is the same, or a binary file, but put into Intel hex format, which is kind of a universal format for flashing stuff to devices. So that's nice. That's easy. We can work out how to do all that. We're just going to come back to this file. What's in the POSIX file? All right. Oh yeah, this is horrible. This is like exactly what you never do. Um, they're tying me to like a really specific release of a compiler. There are reasons, and if we were doing in a working in a traceable industry, we would want that. But as generally distributed file, we definitely don't. And if you look at the device, that's not something for a regulated industry. That's a toy. We are not. We're not worried about having to use a specific version of a compiler so that we can guarantee exactly matching binary output. So we aren't going to do that. That'll be fine. And all right, we don't have to worry about any of that. That's all toolchain file stuff. That's grand. All right, we are not going to get to making the toolchain file in this session. I'm only going to go for an hour. It has been a long week. I do want to go see my wife. Okay, so top level CMake lists, that's fine. Source CMake lists. That's fine. Alright, let's add a target. Add executable. And our executable is going to be... did we give it a name? Yeah, we're just gonna call it the project name. Dot. No, not dot bin. It's the dot out. The dot out is the unfiltered. Oh, and we need to get. I also need a variable that collects all of the source files in this folder. File glob. Oops. File. I have to look up the file glob syntax. Just a second. Let me go back over here. It's just a file command. Oh, I got every. Oh, there we go. That'll be fine. File glob. There we go. This is our command. All right, file glob. Output variable and my globbing expression. This will be fine. We don't want to list directories. Not interested. Configure depends. Not that interested. Just put the globbing expression in. Okay, so file glob variables. Go back over here. Glob variable name is. I'm just going to call it src, and it's going to be star.c, star.cpp. Any C or C++ files in here are part of the thing. Okay, and we also need to add SDK files. All right, and that should give us most of what we need. All right, I'm gonna, because I don't have a toolchain file defined yet, and I'm not actually going to run a build. I am going to take this check on cross-compiling out for the moment, and we're just going to go down here, and we're going to try to run a build. We're going to try to run a build. We're going to try to run CMake, see how we are. If you haven't used CMake before, we prefer out-of-tree builds, meaning that the binary objects and artifacts that we create are not in the same folder as our source. So hence the build folder. And we do that, and we go up there. Hey, my CMake is actually in pretty good shape. That's beautiful. I don't really know what that means, but let's look at the make file at this level. I don't think anything in here will be very exciting for us. There's nothing really radical up here. No, nothing really exciting in there at all. The SRC folder could get interesting. Let's have a look what's in there. Boilerplate. Okay, so there's the variables that we defined. So CMake source dir, that's one of those variables that we use. That's right here. And so that has a definition to it. So that's really great. CMake binary dir, that's the directory where we are. So it's kind of nice. We can actually see that it's paying attention to what we're doing. And I'm curious if there is a SDK root variable defined here. There is not. Alright, I guess I shouldn't be that surprised by that. Let's see if it finds anything. From here, there isn't. Nope. Okay. So, not all the variables really get propagated that way. They must get expanded out. Let's go back into the source folder and have a look. Alright, what's in the CMake outdoor files? Let's go look at that again. Okay, so we put that dot out on the end, so that's us. That's cool. Bluetooth toy, does that show up in there? Look at that, Bluetooth toy that out does. So, okay, I feel kind of good about that. It's a very promising sign. Oh, look at that. This command's going to go up and build. This was that boards.c file. It's going to go do that. And there's a lot of, I mean, this is kind of noisy, but. A target to build an object file. So this is a really, really big, it's doing a lot of redundant work that we would never do when we were writing our own CMake file. But that's the beauty of automation, is it doesn't have to. Okay. So that's what we've got, and that's working. It has been just about an hour, and I want to thank you for sticking with me. Just to see what we're working on here tonight. And I'm going to commit this and push it, and this will become part of our repo, and you can look at it anytime you like. The build folder doesn't have anything I want in it, but that's what's in the source folder. I don't want to get rid of that make file yet because it has information that I want. I'm not going to push that CMake. I'm not going to push that make file to the Git repo. Let's see. So there's our status. Yeah, that looks good. Okay. committed. Let's push it. Okay, it's pushed. It's out there if you want to go look at it. That there is the URL to go find it at. GitLab.com, not GitHub, but GitLab. And Clay Dowling / Bluetooth-toy. All right, folks, thanks for sticking with me for an hour here, and enjoy your Friday evenings. Good night.